Sathyabama Institute of Science and Technology.
Have a good day, students. I am Dr. K. Bhuvaneswari, Assistant Professor, Department of Mathematics, Sathyabama Institute of Science and Technology. Today, in this video lecture, we are going to see that numerical methods. In particularly, we are going to see what is interpolation. So in numerical methods, we are going to see that interpolation. So what is interpolation? Interpolation is a process of computing the values of y from the given set of tabular values xi, yi, where I varies from 0 to n. And what is extrapolation? Extrapolation is the process of finding the values of y and where x lies outside the interval x0, xn. In general, for both the process, either interpolation or extrapolation, we are using that interpolation only. The applications of interpolations. Interpolation can even estimate the missing or corrupted data points in a sequence. It gives the total or complete data analysis. Interpolation is used in many engineering fields such as signal processing, computer graphics, and numerical analysis. It is used to predict the unknown values of the geographical related data points such as rainfall, noise level, elevation, and so on. So these are the applications of that interpolation. An interpolation can be taken for two type of intervals. So one is equal interval, the other one is unequal interval. So equal intervals, we have two methods, Gregory-Newton's forward interpolation formula and Gregory-Newton's backward interpolation formula. And for unequal interval, we have Lagrange's interpolation formula. So how we can identify whether the values of x's are given in equal or unequal interval? So it is given here. Look at that function y is equal to f of x, which passing through the point x I, yi, that is n plus 1 ordered pairs, and note down each xi is equal to x0 plus h, and h is what? The size of the interval. That means xi's are given in equal interval. For example, if I have 2, 4, 6, 8, then you can say the difference between 2, 4, 6 is what? 2. So that is what my size. So if xi's are given in equal interval, I may use that interpolation formula, that is Gregory-Newton's forward and Newton's backward interpolation formula. So where I can use that Newton's forward interpolation? If my x values is near the beginning of the given data, I may use that Newton's forward interpolation formula. And where I can use that Newton's backward interpolation formula, if I have that values which is lies outside or near the end of the table, I may use that Newton's backward interpolation formula. So here I have given what is Newton's forward interpolation formula, where it can be used if my x values are given in equal interval. At the same time, if my x is near the beginning or the first half of the table, given table, I may use that Newton's forward interpolation formula. So here that data are given like this, say x0, y0, x1, y1, x2, y2, x3, y3, so on, xn, yn. So it means you have n plus 1 pair of elements. Now, what is that Newton's forward interpolation formula? It is given as a polynomial. It is called the interpolating polynomial. So that is Pn of x is equal to y0 plus u by 1 factorial delta y0 plus u minus 1 by 2 factorial delta square y0 plus u minus 1 u minus 2 by 3 factorial delta cube y0 plus so on. And what is u here? U is x minus x0 by h, and x is the given value in the question and x0 is the initial value which is given in the table. And h is what? The length of x, that is that interval of x. So this is what that Newton's forward interpolation formula. And I said that where we can use that Newton's backward if my x is near the end of the given table, or if it lies outside the table, I may use that Newton's backward interpolation formula. So what is this formula? Y is equal to Pn of x, or you may say it is f of x, that's equal to yn plus v by 1 factorial del yn plus v plus 1 by 2 factorial del square yn plus v plus 1 v plus 2 by 3 factorial del cube yn plus so on. So it is a finite values where v equal to x minus xn by h. This is what that backward interpolation formula. And now we have used that operators, what is forward and backward. So here in Newton's forward interpolation formula, I have used that operator delta, that's called forward difference operator. So how it is going to be defined? And similarly, in this backward interpolation formula, I have used that operator called del. It is what backward difference operator, how it is going to be defined. So that is given in the next. So what is the finite difference? The known values of the independent variable, that is what your x values, are equally spaced. That means my x values are given in equal interval. I may define that differences, that is finite differences. So the finite difference of y equal to f of x for the given data, or the datas are given in the table like this. Now the first finite difference of y is defined like delta y naught, that is equal to y1 minus y naught. So we are taking these two elements. So you find the difference between y1 and y2. So that is what my delta y naught. And if I take y2 and y1, that gives you that delta y1. So similarly, I can find out all the first differences. Then how can I find the second difference? So that is given by delta square y naught. That's equivalent to delta of y naught. Already I know what is delta y naught. What is delta y naught? That's y1 minus y naught. So that is taken here in the place of delta y naught. Then delta of y1 minus delta of y naught, which gives you that delta square y naught. So this is what that second difference. So similarly, I can find all the successive second differences. Then nth difference can be determined by using this formula, delta power n y naught equal to delta power n minus 1 into y naught. And what is that backward differences? The backward difference of y equal to f of x is defined here. So let us see what is the first backward difference. That is del y1 equal to y1 minus y naught, and del y2 equal to y2 minus y1. But this difference already we have seen, where we have seen in that forward difference. In the forward difference, we said that y1 minus y naught equal to delta y naught. But the same difference is defined here like del y1, because my definition of del operator is del of f of x is equal to f of x minus f of x minus h. So that is why we have started from del y1. I could not find out del y naught, because if I want to find out del y naught, I need what is y minus 1. So y minus 1 is not in the table. So we cannot find out del y naught. So that is why we started from del y1. So del y1 is equal to y1 minus y naught, and del y2 is what? y2 minus y1. Like this I can find out the successive first differences. Similarly, the second difference is determined here, that is del square y2. So we can't find del square y1, the same reason what I said for del y1. Now, what is del square y2? Del square y2 is equal to del y2 minus del y1. Like this, I can find out what is del square y3, del square y4, so on. And what is my nth difference? Del power n yn is equal to del power n minus 1 yn minus del power n minus 1 yn minus 1. So, this is what according to the definition of the finite differences forward and backward, we have determined all these values, and these values we can put it in the table form. So, the first one is the forward difference table. For example, I have taken that 6 datas started from 0, x0, x1, x2, x3 till x5. The corresponding y values are given here. And now let us find the first difference, second difference, third difference, fourth difference and fifth difference. So, that differences are taken. The difference between y1 minus y0 is delta y0, and y2 minus y1, that is delta y1. Like this I can find the first differences. So, I could not find delta y5. Okay, if I want to find delta y5, I need y6. So, y6 is not in the table. So, I could find only delta y4. Now, when I go to the second difference, I can write delta square y0, that is difference between these two, delta y1 and delta y0. Similarly, delta square y1 is difference between these two, delta y2 and delta y1. Like this I can find out the second difference. Then we may find what is third difference, fourth difference and fifth difference. And now you look at that table. So, y0, delta y0, delta square y0, delta power 3, delta power 4, delta power 5 y0. But I could not find out all that y5, delta y5, delta square. So, see, look at that in the downward. We cannot find out delta y5, delta square, delta cube y5, everything. Like this, one suffixes will be reduced. At last I am getting delta power 5 y0. Similarly, I can take that backward difference table. So, here again the same example datas are taken, that is x0 to x5, the corresponding values of y which is given like y0 to y5, and here that backward difference, again the same difference, y1 minus y0, but it is written as a del y1, and y2 minus y1, it is written as del y2. Like this I can find out the backward differences, the first differences. Then what is my second difference? That is del y2 minus del y1, that is del square, y2 not y1. Then del y3 minus del y2, it is del square y3. Like this I can find out the second difference and third difference, 4 and 5. And look at the last diagonal. So, I could find y5, already I know y5. To that y5 I found del y5 and del square y5, del cube y5, del power 4, del power 5. But look at that, upward, I could not have y0, delta y, del y0, del square y0. So, all that suffixes are reduced by 1. So, that is what my backward table, right. So, now these are the tables of Newton's forward and backward formulas. Now, let us see the problems one by one. So, the first problem, and here it is given, find the value of y at x is equal to 21 and x is equal to 28 from the following data. And the datas are given. So, x0 20, x1 23, x2 26, x3 29. And like this the corresponding y0, y1, y2, y3 are given. And now I should find out the value of y at x is equal to 21. So, where is my 21? 21 is between 20 and 23. That means it is near the beginning of the table. So, I can divide the table into two parts. So, 2 plus 2. So, the first half I took. So, from that I have x is equal to 21. So, that is why I may use that Newton's forward interpolation formula. And what about that x is equal to 28? That is, it is in the second half. Between 26 and 29, I have 28. So, I may use that backward interpolation formula. So, the reason is given here. So, after finding which formula I have to use, then you should form the table. So, since I am using that forward difference interpolation formula, so we need that forward difference table. So, the datas are given, x is equal to 20, 23, 26 and 29. Like this, y equal to 0.3420, 0.3907, then y values y0, y1, y2, y3s are given. Then I found the table, I mean the first difference, second difference, third difference. The first difference is what? Between these two, the difference between 0.3907 and 0.3420. Like this I have done the first difference, and the second difference is what? 0.0477 minus this. So I will get the second difference, then the third difference. So it is what? My y naught, delta y naught, delta square y naught, and delta cube y naught. Then we may find out what is u. U equal to x minus x naught by h, that is 21 minus 20. What is your x? We want to find out the value of x, that is x is equal to 21. So I would take that x is equal to 21 and x is what? 20, x naught equal to 20, and h is what? That difference 3. So we will find out what is u, that's equal to x minus x naught by h, that is equal to 1 by 3. Then we may find out what is u minus 1, that's what this answer, u minus 1, u minus 2 is what this answer, and from that we can calculate what is that polynomial, interpolating polynomial, but we have that x is equal to 21, so we will get a constant. So that is Pn of x is equal to, the formula is written here, and y naught plus u by 1 factorial delta y naught plus u minus 1 by 2 factorial delta square y naught plus so on. Then what is x? X is equal to 21. So y of x, that is y of 21, that's equal to y naught. From the table I have taken that y naught. So y naught 0.3420 plus u into u minus 1 plus u into delta y naught by 1 factorial, that is 1, then u into u minus 1 by 2 factorial into delta square is written, then u minus 1, u minus 2 by 3 factorial. So 3 factorial is 6, so that is what by 6 is written into delta cube y naught. So we have to simplify this step and we will get the answer 0.3581. So y of x is equal to 21 is 0.3581. Then what is that? The next value, x is equal to 28. So to that x value I want to find out the corresponding y. For that we may use that backward interpolation formula, because my 28 is near the second half of the table. So we may use that backward interpolation. So after identifying the formula, I want to know what is my v. So v equal to x minus xn by h. But what is xn? Xn is equal to, this is the table. Yes, xn is what? 29, and I want to find out for x is equal to 28. So x minus xn, that is 28 minus 29 divided by 3. So that step only is given here. V equal to 28 minus 29 by 3. So that is equal to minus 1 by 3 minus 0.333. Then we find what is v plus 1, v plus 1, v plus 2. We have calculated here, and then we may use the formula y is equal to f of x, that backward interpolation formula is given, and we may substitute the corresponding values here. So y of 28 is equal to yn plus v by 1 factorial, that is 1 into del yn plus v plus 1 by 2 factorial into del square yn plus v plus 1, v plus 2 by 3 factorial. So 3 factorial is 6 into del cube yn. So after simplifying this, I am getting this 0.4694. So into that data we found the values of y for the two values of x, that is x is equal to 21 and x is equal to 28. For x is equal to 21, we have used that Newton's forward interpolation formula, and x is equal to 28, we used that backward interpolation formula. Then look at the second question. Problem number 2 is what? Find tan of 36.5 degree from the given table. So the table is given, so all the values, x values are given in degree and y values are given, the corresponding values of y, that is tan of 30 degree, tan of 32, tan of 34, tan of 36, tan of 38, like this tan of 40 degree is given in that y. So x0 is 30, x1 32, x2 34, x3 36, x4 38, x5 40. Then what I want to find out, tan of 36.5. So where is my 36.5? That is here between 36 and 38. So I may use that Newton's forward interpolation formula. Even I may use that backward, but here I have used that Newton's forward interpolation formula. So the formula is given, and for that theta, what is my u? U is equal to x minus x naught. So what is my x? 36.5 degree minus x naught, that is 30 degree, divided by h, the difference between that x values. So that is what? 2 degree. So that is written. So the answer is what? 3.25. So after finding that u, I can find out what is my u minus 1, u minus 2, u minus 3, u minus 1, u minus 2, u minus 3, u minus 4. So all the data we have to find out. So before that, I need the table. The table is what given? Finite difference table for y is equal to tan theta. This is what that forward interpolation formula table is given. That theta values are nothing but your x, 30, 32, 34, 36, 38, 40, and the corresponding y values are given. That is tan of 30, tan of 32, every values are given here. Then we found that first difference, second difference, third difference, fourth difference, and fifth difference of this, and that could be used in that formula, forward interpolation formula. So we found y is equal to tan theta, that is equal to y naught plus u into delta y naught, u minus 1 by 2 factorial delta square y naught, and here delta cube y naught, delta power 4 y naught, delta power 5 y naught, and we have substituted what is u here, then u minus 1, u minus 1, u minus 2, u minus 1, u minus 2, u minus 3, and like this here we have substituted all the values. Then we have simplified, and you are getting the answer 0.73992. This is the value of tan of 36.5 is equivalent to 0.73996. So far what we have seen, that interpolation formulas for equal intervals. So we have seen the two type of interpolation, Newton's forward and backward interpolation formula. So in the next video lecture, we will see the problems of interpolation formula, that is for unequal intervals. So we have one method that is called the Lagrange's interpolation formula. So that we have seen in the second lecture.